All right, calculus. Let's talk about this polar problem. Just like the parametrics one, I think this includes so much good polar stuff here, and basically everything you need. So somebody asked, why are we spending so much time graphing these or thinking about the graphs of these? Because we actually won't ever have to graph any on an AP test. I think knowing how to graph it and having that familiarity will help us on a question like this, because we'll be so much more familiar with like how the graph is constructed, how we can use that, and essentially, I think this question is way easier if you know how to graph these polars. Let's talk about part A. Part A is not too crazy. Find the area. This is a Calc OK question, so just set up your area formula. 1/2 integral from 0 to pi of r squared d theta. We know it's 0 to pi because it tells us. It says it's drawn from 0 to pi. So you could have found that, but it's also given. Final answer was 4.382. 1 point for the limits and the constant out front. 1 point for the integrand, the r squared, and 1 point for your final answer. Pretty straightforward grading here. Part B, find the angle that corresponds to the point on the curve with the x-coordinate of -2. We got to remember our x equation in polar form, because we're going to use that here to set up. So remember x equals r times cosine of theta. Luckily we have that r, it's right up here. So set up your equation, x equals theta plus sine of 2 theta times cosine of theta. And I want to know, when does this equation equal -2? So this is the thing I'm trying to find. Just graph it. You can use the solver function if you want, but just graph it. And you can graph these as if they're x's. So x plus sine of 2x. I hate it when it shows up like that. Sine of 2x times cosine of x. And then graph y equals -2 and find your intersection points. I don't remember the graph of this. I don't remember looking at it, but I don't think it'll be too tricky to find that there's only the one here. Theta equals 2.786. I don't think there's more than one, but I don't have the graph pulled up anymore. Writing this out is 1 point, and then finding your theta is 1 point. I really want to emphasize on these Calc OK questions, you just got to write everything out. Regardless of what you're finding, writing it all out is so important because it's a lot of points on this thing. Part C actually isn't much math. We just got to interpret correctly. So it says for pi over 3 to 2 pi over 3. So look at your graph here. That's about here to here, maybe. Something like that. Dr d theta is negative. This is something we're working with the AB students a lot. What does that say about R? What does it say about the curve? Dr d theta. This is your related rates practice, Nico. Change in R, or delta R over delta theta, to like throw back a little bit. What does that mean R is doing? R is getting closer, or sorry, R is decreasing. If dr d theta, the change in R, as my angle goes around this circle, is negative, it's getting smaller. So that says my distance away from the origin is decreasing. Any combination of that is what we're looking for. This is kind of a weird question because it's great. It's key says information about R, information about the curve. As long as you answered both questions, as long as you said something like R is decreasing, the radius is getting smaller, the distance from the curve is getting smaller, you can almost say this in one sentence and I feel like it could be correct. But they have it split into two. So R is decreasing and the curve is getting closer to the origin is how they split it up. Overall, pretty solid job. Nice work. I'm assuming it's nice work. I'm sure you're doing great. Part D, find the value of theta here that corresponds to the point in the first quadrant with greatest distance from the origin. So think about this, greatest distance. Anytime you hear greatest or least, we're thinking candidate's test. We're thinking absolute max, absolute min, that kind of thing. So we've actually got to maximize our radius function. And luckily they already gave us dr d theta. Not that it's that difficult to find, but we have this equation for dr d theta. So that's going to tell us how is the radius changing over time. And we want to find our critical points. So we've set this equation. I would say set this equal to 0. Or better yet, graph it and see where it crosses from positive to negative, right? Increasing to decreasing. Where is my distance from the origin at its maximum point? Obviously there's going to be two of them. So if you look at this picture, I think one of them is about right here and the other one's about right here. It looks to me like the function is getting further from the origin, from 0 to pi over 3. And then, like it said in part B, or part C, it's getting closer here. And then it's getting further away. And I don't think there's another critical point. So you can graph it, but actually we already have this info. Our only 3 points we need to test are pi over 3, 0, but not really, and then pi. And so that's what they did here. Oh, sorry, only from pi over 2. So we only really need to test 0, pi over 3, and pi over 2. But then again, 0 is not going to be anything. I think we could probably assume it's going to be pi over 3 looking at this picture. Where's the maximum distance? Yeah, it's definitely further at pi over 3 than it is at pi over 2. And here at 0, it's definitely closest. So this question, I don't really know why they didn't make it a little trickier. But I think they're trying to make you apply candidates test rules in a polar function, which is something we're not really used to doing. So that's my best guess. They said, hey, as long as you considered pi over 3, right? Candidates test says consider critical points, consider endpoints. Consider the critical point of pi over 3. And then number 2, answer with justification, and again our justification is this table. So we know that the greatest distance occurs when we're at theta equals pi over 3, because we plugged pi over 3 into our r function above here. R equals theta plus sine of 2 theta. And that's where we got our 3 outputs. I'll write that down here, just so we remember where that came from. That was given to us. So if we plugged each of these thetas into this function, evaluated our r's, drew the conclusion from there. This one wasn't nearly as crazy as the parametric problem, but I still thought it was pretty awesome. So any questions, let me know. Good luck. Have a great rest of your day.